Good evening. In today's class, I am going to explain you some more problems given in previous Jeemain from the chapter System of Particles. In particular, today we are going to concentrate on some more problems based on center of mass and torque. Let's move on to the problems. Look here. See, the previous 23 problems we have already completed. So, let us continue with 24th problem. Time dependence of position of a particle of mass 2 units is given by r bar is equal to 2t I bar minus 3t square j bar. Find its angular momentum with respect to the origin at t is equal to 2 seconds. We need to find out the angular momentum at t is equal to 2 seconds with respect to the origin. So, what is the formula for angular momentum? L bar is equal to r bar cross p bar. So, L bar is equal to r bar cross p bar is linear momentum, that is mv bar. So, here at t is equal to 2 seconds, r bar will be 2 into 2 I minus 3 2 square j bar. So, from this r bar I am writing here 2 2s are 4 I minus 4 3s are 12 j bar, right. And coming to velocity, how do you get velocity from position vector? Well, we get velocity by differentiating position vector with respect to time. So, here by differentiating this with respect to time, derivative of t is 1. So, 2i minus t square derivative is 2t. So, 3 into 2t j bar. Let us substitute 2 in place of t, then velocity at the end of time 2 is 2i bar minus 3 into 2 into 2. So, 4 3s are 12 j bar. So, momentum is mv bar. So, mass is given as 2 here, mv bar, 2 2s are 4 I bar, 2 12s are 24 j bar. So, linear momentum vector is 4i minus 24 j, 4i minus 24 j. So, angular momentum is L bar cross mv bar, or L bar is equal to r bar cross p bar. If you take the cross product, L bar is equal to I cross I is 0, I cross j is k, but there is minus sign. So, it becomes minus k. 4 24s are 96 minus 96 k bar. J cross I is minus k, minus of minus becomes plus. So, 4 12s are 48. So, this becomes 48 k bar. So, L bar is equal to 48 minus 96, it is minus 48 k bar. That is the angular momentum of that particle with respect to the origin at t is equal to 2 seconds. So, this is the correct option for that problem, right. Move on to the next problem. Look here. See, a particle of mass m is moving, I am keeping it here. A particle of mass m is moving along a trajectory x is equal to x0 plus a cos omega 1 t, and y is equal to y0 plus b sin omega 2 t. The torque acting on the particle about the origin at t is equal to 0. Here x I bar plus y j bar gives you the position vector. Torque is equal to r bar cross f bar. So, first of all, you are supposed to find torque at t is equal to 0. So, let us write r bar at t is equal to 0. If t becomes 0, sin omega 2t becomes 0. So, y component becomes only y naught. Cos omega 1t becomes 1 because cos 0 is equal to 1. So, the position vector at, I am writing it here, the position vector at t is equal to 0 is x0 plus a I bar plus, because this entire component becomes 0, plus y naught into j bar. That is the position vector. Am I clear? Now, you want to find out, see, torque. Torque is equal to r bar cross f bar. F is equal to m a bar. If position vector is given, how to find out acceleration? By differentiating position vector with respect to time once, you get velocity. Again, by differentiating velocity with respect to time, you get acceleration. Meaning, you have to differentiate the position vector twice with respect to time in order to get acceleration. Let us do that carefully. See, from this, if you differentiate this, Vx is equal to derivative of constant is 0, derivative of cos is minus sign. So, it becomes minus a omega 1 sin omega 1 t. So, acceleration component becomes derivative of sin is cos. So, minus omega 1 square a cos omega 1 t. Exactly in the same way, if you differentiate this twice, acceleration component becomes minus omega 2 square b sin omega 2 t. At t is equal to 0, this term, entire term becomes equal to 0 and this term becomes equal to 1. So, at t is equal to 0, acceleration becomes, see, acceleration is minus omega 1 square a I bar, minus omega 1 square a I bar. I think we need not write it so distant, isn't it? I'll write it here, okay? So, this is acceleration. Now, mass is equal, what is torque? Torque is equal to r bar cross f bar. R bar is equal to x naught plus a into I bar plus y naught j bar cross m, because minus is there, minus m omega 1 square a I bar, that is r bar cross f bar. I bar cross I bar becomes equal to 0, j cross I is minus k, minus of minus 1 becomes plus 1. So, it becomes y naught, torque is equal to y naught m omega 1 square a. So, see how the options are given into k bar, into k bar. See here, it is given like this, m is written first, m y naught a omega 1 square k cap. That is the expression for the torque. It's a beautiful problem, isn't it? So, only mass and position vector are given. From that we could calculate the torque. So, torque is r bar cross f bar, where f is m into a. We get acceleration by differentiating position vector twice with respect to time. Move on to the next problem. Look here. See, to mop clean a floor, a cleaning machine presses a circular mop of radius r vertically down with a total force F and rotates it with constant angular speed about its axis. Force is distributed uniformly over the mop and coefficient of friction between the mop and the floor is mu. torque applied. So here actually torque is r bar cross f bar. So r is the radius vector, f bar is the tangential force, that is the friction here. You just imagine a mop. See, there will be a stick here and it may be a motorized one. This stick applies the force in the downward direction spread over the entire circular mop. So the pressure exerted by the circular mop on the floor becomes force into area. R is the radius of the circular mop, area becomes F pi r square. This is the total pressure exerted on the entire area. Now, let us try to find out the force exerted on a small angular disc of radius r, thickness dr of the mop. So, the area of that becomes area of that circular annular disc considered is 2 pi r into dr. So, the force exerted on that circular annular disc is for pressure into area. Pressure is distributed uniformly. So, pressure into area. Pressure is F by A, isn't it? Force per unit area. So, force is equal to pressure into area. So, force exerted on the annular disc, let us call that as a normal reaction, that is equal to F by pi r square into area of the annular disc is 2 pi r into dr. So, pi and pi gets cancelled, that normal reaction on that annular disc becomes F by r square 2r into dr, right? That is the normal reaction. Now, frictional force is equal to mu into normal reaction. So, frictional force is equal to mu F by r square 2r dr, right? And now, the torque produced by this frictional force present on that annular disc becomes, it is r cross f. Here r and f are mutually perpendicular. So, the torque exerted is, the net torque exerted is, by integrating this we get that. So, it is mu f r square by 2r into r dr. This is the net torque. Is it okay? So, here let us take the constants outside the integral, 2 mu f by r square into r square dr. So, the torque is equal to 2 mu f by r square into r square integral is r cube by 3, r cube by 3, and the limits will be 0 to r. Actually, the total radius of the entire circular mop is r. We have considered an annular disc of radius small r and thickness dr. So, that thickness extends from 0 to capital R. That is why we have integrated that within the limits 0 to r. So, this becomes 2 mu f by r square into r cube by 3. So, this is 2 mu f r by 3. That is the expression for the torque. So, this is the correct option for that problem. Okay? Move on to the next problem. Look here, center of mass of thin rectangular plate with sides of length A and B whose mass per unit area sigma varies with the expression sigma naught x by AB. This indicates its mass is varying only along x axis with respect to y coordinate, or along y axis it is not changing, right? So, what you are asked to find out the center of mass coordinates with respect to the origin. Very obviously, as this is B, y coordinate, because mass is not varying along y axis, definitely y coordinate will be b by 2. Look at the options, only this option is eliminated. All the 3 other options, y coordinate is straight away given as b by 2, that is perfect. Now, we have to follow the x coordinate very carefully. So, here xcm is equal to sigma naught x dx by AB into x divided by integral sigma x dx, right. So, here it becomes sigma naught A by, okay, see here, let us take this out, let us find it separately. So, here first let us try to find out the mass. Mass is equal to sigma naught x by AB into area. So, you have to integrate that with respect to x, because along with x axis its mass is varying, along with y axis there is no change. So, mass becomes sigma naught x by AB, x varies from 0 to A. So, mass is equal to sigma naught x dx is x square by 2, but x is equal to A here. So, it becomes sigma naught A square by 2 AB, or mass is equal to sigma naught A by 2B, that is the mass. Now, along this the center of mass x coordinate of center of mass is given by sigma naught x by AB. This is mass density, sigma naught x by A into B into x dx divided by sigma naught x by AB dx. This is the total mass. So, let us do it carefully. See here, this is x square integral is x cube by 3. So, it becomes sigma naught by AB into x cube by 3. This is sigma naught by AB into x square by 2. Okay, you have to integrate that within the limits 0 to A, because along x axis it is extending up to A. Actually, sigma naught by AB, sigma naught by AB gets cancelled. X cube by x square, it becomes x. This 2 goes to the numerator. X center of mass is 2 by 3 into A. Y center of mass is just at the midpoint, that is equal to B by 2. The coordinates of center of mass are 2 by 3A comma B by 2. That is it. Actually, you need not find this, this step is unnecessary. You need not do it separately, straight away you can do it. Is it all right? So, here by looking at that you can understand it is varying, mass is varying only along x axis, along y axis it is not changing. As a result, the center of mass coordinate with respect to y axis is B by 2. So, just we found the x coordinate of center of mass. Okay? Move on to the next problem. Look here, an object of mass m projected from the origin in a vertical xy plane at an angle 45 degrees with the x axis. Let us consider this as x axis and vertical direction as y axis. So, when a body is projected at an angle 45 degrees with a velocity u, it is with a velocity u is given as v naught here. Magnitude and direction of angular momentum of the object with respect to the origin at the maximum height. Look here. What is angular momentum? L bar is equal to R bar cross P bar. So, here P bar, let us see P bar here. Momentum of a projectile at the highest point is m u cos theta along positive x-axis in this reference. And here this is height along positive y-axis. So, angular momentum R cross P, that is m u cos theta into perpendicular distance is h here, I cross j becomes k bar, because this is I and this is j bar, I cross j is k bar. So, angular momentum of a projectile at the highest point is mu cos theta into maximum height reached. So, this is mu cos theta, maximum height reached by a projectile is u square sin square theta by 2g. From this expression, you can see angular momentum is half m u cube sin square theta cos theta by g. That is the half m u cube sin square theta cos theta by g. That is the angular momentum expression for a projectile at the highest point. So, here let us substitute the given quantities. Mass is given as m, velocity is given as v0, theta is given as 45, sin 45 is 1 by root 2, sin square 45 is 1 by 2, cos 45 is 1 by root 2 by g. So, this is m v0 cube by 2 2s are 4, 4 root 2 k bar, that is what we got. K is nothing but k is a unit vector along positive x-axis. So, here in this case angular momentum is m v0 cube by 4 root 2 along positive x-axis. That is the correct answer for that problem. Move on to the next problem. So, options for the same. Now, look into this problem carefully. Two blocks of masses 10 kg and 30 kg are placed on the same line with coordinates 0, 0, x, 0. That means they are lying on x-axis, because in both cases y coordinate is 0. If the block m1, let us take this as m2, 10 kg is moved on the same line through a distance 6 centimeters. See here, let us take this as the origin, m1 is located at the origin, m2 is located at some point. It is located at x, 0. This is moved towards the other block through a distance 6 centimeters. Right? The distance through which the block 30 kg is moved to keep the position of center of mass of the system unchanged. In general, x coordinate of center of mass is given by m1 x1 plus m2 x2 by m1 plus m2. Change in the location of center of mass is given by m1 delta x1 plus m2 delta x2 by m1 plus m2. Here in this problem he mentioned that first particle is moved through a certain distance. What should be the displacement of the second particle so that the shift in the center of mass is 0? That is delta x cm is 0. That implies m2 delta x2 is equal to minus of m1 delta x1. So, delta x2 shift in the location of the second object must be minus m1 is 10, it is moved through a distance 6 centimeters towards this, divided by m1 plus m2, 10 plus 30, it is 40. So, this is 1.5 centimeters. So, second, is it correct? I think, look here, So here 10 kg is moved on the same line through a distance 6 centimeters and 30 kg must be moved. So here, this is not 40, isn't it? So here I went wrong. See, this is m1 delta x1 by m1 delta x1 by m2. So m1 is 10 here, x1 is 6 here, m2 is 30. So 30, so this is 2 centimeters. Minus sign indicates it is moved along negative x-axis. So here this is moved 2 centimeters in this direction, that is towards m1. So 2 centimeters away from 10 kg, 2 centimeters towards 10 kg block. So it is moved towards 10 kg block. Okay, so that is so simple. If there is no shift in center of mass, m1 delta x1 is equal to m2 delta x2, they will be in opposite direction. That's it. Now look into this problem carefully. As shown in the figure, a spherical cavity. See, let us consider this as a spherical cavity. Spherical cavity of radius 1, centered at O. So this radius is given as 1, centered at O, is cut from a uniform sphere of radius R, centered at C. So the radius of this sphere is given as R here. Its center of mass is at C. Center of mass of the remaining part of the sphere, this is, if you remove this part, so this is the remaining part. Center of mass of the remaining part is at G. This is the center of mass of the remaining part. On the surface of the cavity, R can be determined. That problem is simple, but you have to understand what they have given in the problem. So learn how to draw the diagram. Actually, the diagram is given in the question, but even if it is not given, you can take down the diagram like this. As shown in the figure, a spherical cavity is removed from a sphere and spherical cavity of radius R, radius 1. So this is the spherical cavity centered at C and radius is 1. Removed from a sphere whose center is, this is centered at O and sphere center is given as C and the sphere radius is given as R. So when this is removed, the center of mass shifts away from the original center. Actually, it has shifted to this point. It is given that the center of mass of the remaining part G, it lies on the surface of the cavity. Then R can be found from that equation. So here we know the total mass of the sphere m1 is taken as 1 here. So mass of the cavity, mass is proportional to R cube. Mass is proportional to volume, that is 4 by 3, volume of a sphere is 4 by 3 pi R cube. In case of the sphere, let us take the proportionality constant 4 by 3 pi as 1. So mass of the entire sphere becomes R cube, then mass of the cavity becomes 1 cube, that is 1. Now distance of center of mass of the cavity from the center of mass of the original sphere, that is R minus 1. Okay, then shift in center of mass, delta x is equal to, we know the formula, minus m2d by m1 minus m2. That negative sign merely indicates the shift in center of mass is in a direction opposite to the removed part. So as the part is removed here, it shifts away. Just that negative sign indicates the direction. So delta x is equal to m2. D is r1 minus r2 by m1 minus m2 is r cube minus 1. So, from this delta x is equal to r minus 1 by r cube minus 1 can be written as, you know, all of you know this, isn't it? R square plus r plus 1. Here, what is delta x? He mentioned that the center of mass of the remaining part coincides with the edge of the removed one. So, here this entire thing is 2, 2 minus r is delta x. So, 2 minus r, see here, this is, radius is 2, so this entire thing, radius is 1, so the diameter becomes 2, 2 minus r is shift in center of mass. So, 2 minus r is equal to r minus 1 by r minus 1 into r square plus r plus 1, this and this gets cancelled. So, you are left with, look here, if you take this to the other side, this to the other side, on cross multiplication, r square plus r plus 1 into 2 minus r is equal to 1. Using that relation, you can find out r. So, first option is true. Okay. Now, move on to the next problem. Look here, a uniform rectangular thin sheet ABCD of mass capital M, length A, breadth B is as shown in the figure. Shaded portion is cut off. The coordinates of center of mass of the remaining portion with respect to O. So, let us forget about that shaded part. For this, mass is concentrated at this point. Its mass, let us take it as 1. Okay. And we write the coordinates later. This portion here, center of mass will be here, center of mass will be here. As all the three are of equal masses, let us take the mass as 1. So, this I am writing the coordinates for the first particle. Mass is 1, x coordinate. This is A, up to this A by 2. So, up to this it will be A by 4. Okay, and y coordinate is also, it is b by 4. Now, let us write the coordinates of this. This is 1, this distance 3a by 4, 3a by 4, comma y coordinate is b by 4. Let us write the coordinates of this particle. 1, x coordinate is a by 4. But y coordinate is this, b by 2 plus b by 4, it is 3b by 4. So, you are supposed to find the coordinates of center of mass. So, the formula for x coordinate is m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. Similarly, y coordinate is m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. Now, x coordinate of center of mass is m1 is 1, x1 is a by 4, a by 4. Okay, m2 is 1, x coordinate is 3a by 4, m3 is 1, x coordinate is a by 4. By the total mass is 3. So, what do we get here? X coordinate of center of mass is xcm is equal to, you can take that a by 4 as a common factor, a by 4 into 1 plus 3, 4 plus 1, 5. 5 divided by 3. So, xcm is equal to 5a by 12 and ycm by similarity we can say it is 5b by 12 because 1 here it is b by 4, isn't it? 1 b by 4, 1 b by 4, 1 3b by 4. So, exactly by considering the same formula you will be getting it as 5b by 12. So, look into the options given. This is the correct answer. 5a by 12 and 5b by 12. Okay, look into the next problem. See here, follow this problem very carefully. See, it's a lengthy problem. Now I am going to tell you something after completing this problem, so follow me very carefully. See here, keep the problem here. Position vectors of two 1 kg particles. Mass of each particle is 1 kg. Position vectors are RA is alpha 1 T square I, alpha 2 Tj, alpha 3 Tk, where alpha 1, alpha 2 are given here. I am substituting straight away here and I am writing the position vector of the particle A. Alpha 1 is given as 1 into T square I, alpha 2 is given as 3n. So, plus 3n into T j, alpha 3 is given as 2. So, plus 2t k. So, I will write the position coordinates of the particle as t square, x coordinate is t square, y coordinate is 3n into t, 3n into t, and z coordinate is 2t. Z coordinate is 2t. Similarly, let me write the coordinates of B. So, here I think we can directly substitute. So, substitute B1 as 2 here. So, it becomes 2 into t, x coordinate. Now, B2 minus 1 into t square. So, minus t square, and next one B3 is 4p. So, it is 4p into t. They are the position coordinates of A and B. You have to write the position coordinates very carefully. So, I am checking it once again. Beta 1 is given as 2, so 2t. Beta 2 is given as minus 1 into t square, minus t square. Beta 3 is given as 4p into t. So, 4pt. They are the position coordinates of the two particles. Now, n and p are constants. At t is equal to 1, magnitude of A and B are magnitude of their velocities are equal. How do we get velocities? We get velocities by differentiating this with respect to time. So, velocity coordinate becomes t square derivative is 2t, 3nt derivative is 3n, 2t derivative is just 1, so it is 2. Similarly, velocity of B coordinates, derivative of t is 1, so derivative of minus t square is minus 2t, derivative of 4pt is 4p. It is mentioned in the problem at t is equal to 1, magnitude of the velocities are same. At t is equal to 1 second, what is the magnitude of A? It is square root of 2 square plus 9 square plus 2 square. 2t is 1. So, and similarly, velocity magnitude of velocity of B is 2 square plus 2t whole square is 4t square plus 4p, t square is 1. So, it just becomes 1 plus 4p. So, what is 4p whole square? 16p square. So, 4 is nothing but 2 square. So, if you equate these two, magnitude of VA is equal to magnitude of VB implies 9n square is equal to 16p square. From this, n is equal to plus or minus 4 by 3p. This is one value we got. Keep it aside. And in the next step, velocities of A and B of the two particles are orthogonal at t is equal to 1 second. So, at t is equal to 1 second, if velocities are orthogonal, their dot product must be equal to 0. So, dot product of these two velocities. So, V A bar dot V B bar is equal to 2 2's are 4 because t is 1, 3n minus 2 minus 6n, 2 4's are 8 plus 8p, this is equal to 0. Now, substitute the n value here. What do we get? 4, this is 4 minus 6 n. We can take this as, we have to take either plus or minus depending on the, see you know how to take the sign here. Suppose if you take this as plus 4 by 3. So, n is equal to 4 by 3p. So, 6 into 4 by 3p plus 8p. So, very obviously minus 8p plus 8p, it becomes 4 is equal to 0, which is impossible. So, that implies n is equal to minus 4 by 3p. Do you understand? That is an important thing. So, here from this, what did you get here? So, 4 plus 8p plus 8p, 16p is equal to 0, 16p is equal to minus 4, or p is equal to minus 4 by 16, that is minus 1 by 4. As n is equal to minus 4 by 3 into p. P is minus 1 by 4, minus minus plus plus. So, n is equal to 1 by 3. Ultimately, we got these values. Problem is not yet completed. Look here. Then what is asked? At t is equal to 1, what is the magnitude of angular momentum of particle A with respect to the position of B? So, angular momentum of A with respect to B, that is angular momentum of the particle A. So, m into VA into RB minus RA, RA minus RB, RA minus RB, angular momentum of A with respect to B. So, actually you have to write R cross B. So, if you take this as R bar cross M VA bar, that is what you need to find out. But actually here the magnitude is asked, but anyway you have to find R bar now. R bar is RA minus RB. So, RA minus RB at t is equal to 1. So, at t is equal to 1, 1 minus 2. So, R bar is equal to 1 minus 2 is minus 1, that is I bar. 3n, what is the n value? 1 by 3. 3 into 1 by 3 is 1, t is 1. So, 1 minus of minus 1, it becomes plus, so plus 2j. Now, 2, t is 1, p is 1 by 4, 4 and 4 gets cancelled, that is minus 1. So, 2 minus of minus 1, it becomes plus, so it is 3j. So, RA minus RB, 1 minus 2, minus 1, 1 minus of minus 2, 2 minus of minus 1, that is 3. And momentum, P is mv bar, mass is given as 1, so just V A bar, it is 2 I bar, 3 n is 1 by 3, gets cancelled, plus j bar, and this is 2k bar, plus 2k bar. So, now you have to find out R cross P. So, let us try to find out R cross P from this expression. look here. So, you have to R bar cross P bar is equal to determinant I, J, K minus 1, 2, 3, 2 plus 1, 2, 1 and 2. So, this is I into 2 2s are 4 minus 3 minus j into 3 3s are 9, 9 minus of minus plus 2, okay, 3 2s are 6 not 9, 3 2s are 6 plus 2 plus k minus 1, 2 2s are 4 minus 4. So, this is I into 4 minus 3 is 1 minus j into 8 plus k into 5. Okay. So, here this is R bar cross P bar. So, its magnitude now becomes, magnitude of L becomes square root of 1 square plus 8 square plus 5 square. So, this is 90. 64 plus 25 is 89. So, this is 90. So, it is given as root L here. So, we got it as root L is root 90. The value of L numerically equal to 90. That is the answer. Now, I am telling the strategy of solving the problem. See how much time. Here, there are two risks in the problem. It takes a long time. However sharp you are, it takes long time. Okay, and another thing is you have to be very, very cautious because so much calculation is there. So, at the end of the day, we might go wrong somewhere. So, actually, if you are capable of getting 100 percentile, you should attempt this question in Jeemain. Otherwise, it is better leave for the end. Complete the entire question paper, leave this kind of lengthy questions till the end. If you have enough time, only then solve those questions, and if you get the right answer, then you can put the right option there, choose the correct answer there. If it is a numerical value, risk will be much more higher, isn't it? Okay, so I'll stop here for today. I'll continue in the next session with some more interesting problems with some more tips. So, thank you and bye-bye.